Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is leftmost and rightmost nodes of a binary tree, and it is a medium level problem. So this particular problem says that we have been given a binary tree of size n and we have to print the corner nodes. So let's say this is the binary tree that they have given to us. Now for each of the levels, for example, this is the first level, this is the second level, and this is the third level. Right. So for each of these levels, we have to print the first and the last element of that level. And obviously, if the first and the last element are same as for in this particular case, you just have to print it once. So you see, we have first printed 1, then we have 2, 3, 2 and 3 here, and then 4 and then 7. So we have to print the first and the last element of each of the levels, and this is our whole problem. So there are actually multiple ways of solving this particular problem, and you can go with any one of them. So I'm just going to give you a brief idea of another way which I have not implemented, but if you want, you can also try it. So first of all, let me tell you an idea which will work, but I have not implemented my summation that way. So the core idea in both of the methods is that you want to somehow differentiate between the levels, right? So if you are able to differentiate between the levels, you can easily find out which nodes belongs to which level. So for example, this is 0, 1 and 2, right? So if you know what are all the nodes in level 0, if you know what are all the nodes in level 1, if you know what are all the nodes in level 2, then you can easily write down your first and your last node of each level. So what you can do is you can have a level variable initially for -1, and for this node it is going to be 0. So whenever you encounter a node which has a level different from this level variable, that means you have started on with a new level. So you will do two things. First of all, you will print the last element of the previous level and you will print the first element of the current level. Since you are at level 0, it does not have any previous level, so you are not going to print anything for the last level, but for the current level, you are going to print this first character. Now for example, you are currently at level 1. Now your level variable would have been 0. You come at level 1. You realize that your level has changed. That means you are currently at the first node of a new level. So you will have to print it. But you can also check at the same time how many elements were there in the previous level. If it is only equals to 1, you don't have to print the previous level's last node. Right. Now I printed and I'm just going to traverse to this level. I also have a variable called last, which is going to store the last node at my current level. So by the time I traverse this level 1, my last variable will have this particular node. Now when I come to level 2, my level variable would have been initially 1. I come at level 2. I see that there is a previous level 1 and I am currently at the first node of the new level. Right. So what I can do, I can first print the last node of the previous level and then I can print the first node of the current level. And then I can keep on traversing this particular level and keep on updating my last pointer. Now how do you maintain the level of each node? You can push a pair. Instead of pushing just the nodes, you can just push a pair of nodes and integers, right? So this node will be pointing to the node and this will be storing the level of any node, and whenever you insert a new child to the queue, its level will be current level plus 1. So now let us discuss another way of solving this problem in which you don't have to maintain so many things. That is why I implemented my solution that way. So in this particular method, we are going to maintain a temporary queue. So generally while we are doing level order traversal, we have a normal queue. Right, so this will be storing nodes and this is queue. So now what I'll do, I'll push my root node into this particular queue. Now, obviously I'm just going to maintain a while loop while my queue is not empty. So I'm going to perform some operations on it. What I'll do, I'll create a temporary queue inside it. So this will be of also nodes and this will be a temporary queue. Now all the children of my current level are going to be stored in this temporary queue. So I'm again going to write while my queue is not empty and all the elements that I pop from here, right? For example, if I have a node here, it has a left child and a right child, right? So both of these left and right child are not going to be pushed in the queue directly. They're both going to be pushed in the temporary queue, right? So how does this help us? I initially said that the main idea in both of the problems is to somehow differentiate between the levels. So if I push all the children of my current level into some other queue, that means I'll be able to figure out that all those children are of some other level. right? So this is how I'm trying to differentiate between the two levels. Now, once I find out what is the first and the last node of my current level, I can print them at the end, and after it, I can assign my q is equals to 10. Right, so this is how you can solve this particular problem. I'm using the temporary queue to store all the nodes of the next level, and this is how I can differentiate between the two consecutive levels. Normally what happens in a single queue, all the nodes that you have are pushed into the single queue. So you're not able to differentiate between two nodes of different levels, and this is how you can do it easily by creating a temporary queue. So let us see how I have implemented it. So see, what I've done is I've created a main queue of node pointers and I've pushed the root node into it. Right, now while my queue is not empty, I initialize a temporary queue next, and I'm just going to store the first and the last pointers. So the first pointer of the current level is obviously going to be queue front, and I'm also initializing the last pointer with the same pointer as well. Now I'm just going to run a while loop while my queue is not empty. What I'm going to do, I'm just going to initialize my current node as queue.front, and I'm going to update my last each time I enter inside this particular loop. After it, I pop it from my queue. Now if my current left is not null pointer, I'm just going to push it into my next queue. If my current right is not null pointer, I'm just going to push it into my next queue as well. And after all of this has been done, I can just update my queue as next. Right, now I have to print first data because this is the pointer of the first node at this particular level. And if last is not equals to first, I'm also going to print last data. So this is how you can solve this particular problem. And let me just quickly submit this so that you know that this particular code works. So you see, it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always subscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.